Welcome students. Let's start lecture number 5. Okay, so before going to start our fifth theorem, let's do one activity. In this activity, we have to draw three parallel lines and two transversal. Okay, so let's draw it first. Here I am going to draw three parallel lines first. According to the properties of parallel lines, we know that distance between two parallel lines is fixed. So I am fixing the distance here and drawing one more line. This is approximate parallel line. You can draw in a more proper way that you learned in previous standard. Okay, so this is third line, line L, line M, and line N. Okay, as per the instructions, I am giving the name. Now we have to draw two transversals. This is the first transversal I am going to draw, transversal T1. And this is second transversal. This is transversal T2. Give the name T1 and T2. Now we have to mention the name for intersection points. Okay, so A, B, and C are the intersecting points of a transversal with line L, line M, and line N respectively. Similarly, for T2, P, Q, and R are the intersecting points for line L, line M, and line N respectively. Now I have to find distance between point A and point B. Using scale, I got the value 3.2 centimeter. So AB is 3.2 centimeter now. BC. BC is 4.2 centimeter. PQ. PQ is 3.3 centimeter. Around 3. Approx 3.3 or 3.4. I am taking 3.3 here. Try to avoid human error. And the last one is QR, which is 4.4 centimeter. So finally, I got AB is equal to 3.2 centimeter. BC is equal to 4.2 centimeter. PQ is equal to 3.3 centimeter and QR is equal to 4.4 centimeter. Okay, from the activity I am writing these values. So if you observe this, AB upon BC and PQ upon QR, you will find this ratio is fixed. This ratio is same. See, this value is 0.76. You can find this value by using calculation. And again here 0.75, approximately same. The difference between these two values is, what is the difference? It is 0.01, okay, which is very negligible as compared to 3.2, 4.2, 3.3, and 4.4. Okay, so in this way we will have one conclusion. What is that conclusion? We will find this ratio are almost equal. That is, AB upon BC is equal to PQ upon QR. Now, on the basis of this activity, we will have one property, that is property of parallel lines and their transversal. So theorem for this property is the ratio of intercepts made on a transversal by three parallel lines is equal to the ratio of corresponding intercepts made on any other transversal by the same parallel lines. आता ह्या थेरमचा नक्की अर्थ काय हे आपण आधी समजून घेणार आहोत. त्यासाठी आपल्याला गिवन आणि टू प्रूव्ह या दोन गोष्टी ओळखायच्या आहेत. म्हणून आपल्याला याचा अर्थ पहिला समजणं गरजेचं आहे, कारण मी काल सांगितल्याप्रमाणे इथे इफ देन अशा स्वरूपाचं स्टेटमेंट हे नाहीये. So we have to, our first task is to find what is given and what is to prove. The ratio of, okay, so ratio आपल्याला हवा आहे कोणाचा, the intercept made on transversal by three parallel lines. बघा आता जर मी T1 ही ट्रान्सव्हर्सल घेतली तर ह्या ट्रान्सव्हर्सलने ही एक L नावाची लाईन आहे, ही M नावाची लाईन आहे आणि ही एक N नावाची लाईन आहे. ह्या लाईन वरती हे ए बी आणि सी हे जे पॉइंट्स आहेत ते काय इंटरसेप्ट आहेत. ओके, आता ते म्हणतात की रेशो हा जो आहे हा इक्वल आहे टू द रेशो ऑफ करस्पॉन्डिंग इंटरसेप्ट. बाकीचे इंटरसेप्ट मेड ऑन द एनी अदर ट्रान्सव्हर्सल, कुठली तरी दुसरी ट्रान्सव्हर्सल सध्या आपल्या समोर T2, दिस इज अनदर ट्रान्सव्हर्सल T2 which also making intercept E, Q and R on line L, M and N. So ह्यांचे सुद्धा रेशो आपल्याला तयार झालेले दिसतात. बरोबर. सो रेशो मीन्स नक्की काय, तर ए बी अपॉन बी सी आणि इकडे पी क्यू अपॉन क्यू आर. ओके, सो अशा स्वरूपाचे जे रेशो आपल्याला मिळणार आहेत ते कसे असायला पाहिजे, इक्वल टू. लक्षात घ्या, हे कसे असायला पाहिजे, इक्वल टू. म्हणून आपल्याला गोष्टी दिलेल्या काय आहेत, गिवन मध्ये लाईन एल इज पॅरलल टू लाईन एम, लाईन एम इज पॅरलल टू लाईन एन, जे की इथे म्हटलंय थ्री पॅरलल लाईन्स. या दोन शब्दांवर आपण ही लाईन लिहू शकतो. अँड T1 आणि T2 आहे ट्रान्सव्हर्सल, इथे दोन ट्रान्सव्हर्सल येणार, ही एक ट्रान्सव्हर्सल म्हटले आणि दुसरी पुन्हा अदर ट्रान्सव्हर्सल, त्यामुळे इथे T1 आणि T2 चे दोन ट्रान्सव्हर्सल आपण घेतले आणि ह्या इंटरसेक्ट करतात करस्पॉन्डिंग लाईन्स ना ऍट दिस पॉइंट्स ABC आणि PQR. ठीक आहे, सो हे आपण गिवन मध्ये घेतलं आणि टू प्रूव्ह मध्ये आपल्याला काय दाखवायचं की यांचा जो रेशो मिळणार आहे आपल्याला तो इक्वल असला पाहिजे, हे आपलं थेरम सांगतं आपल्याला. ओके, नाउ let's start proof. So in this proof there is one construction which is draw segment PC which intersects line M at point D. See this? From P to C I am drawing segment PC which intersect line M at point D. Okay, next, in triangle ACP BD is parallel to AP. Now we have to find triangle ACP. Okay, this is triangle ACP. In this triangle, BD, see this much amount only distance. So BD is parallel to AP. Okay, that's true. Therefore, AB upon BC is equal to PD upon BC according to basic proportionality theorem. Okay, if we take this entire triangle and BD is, as we know, BD is parallel to AP, then we can write AB upon BC is equal to PD upon BC, or we can write CB upon AB is equal to CD upon PD. Both are correct. Here I am writing like this. This is the first equation. Okay, and the comment is according to BPT theorem. This is our first theorem in this chapter. Now, in triangle CPR, now CPR is another triangle. This segment divides this region into two triangles. Okay, so first triangle is this and second triangle is CPR. In this triangle also DQ is parallel to CR, and again we are going to apply BPT for this triangle. So finally we left with PD upon DC. Where is PD? PD upon DC is equal to PQ upon QR. This is all these things we have already learned in yesterday's lecture. Okay, I am giving second equation for this step, second number. So according to from 1 and 2, what we get? See this, AB upon BC is equal to PD upon DC from 1, and PD upon DC is equal to PQ upon QR. So we can directly write all these ratios together. So from 1 and 2. Hence, we can say AB upon BC is equal to PQ upon QR. This is the final answer that we have to prove. Okay, the next problem is actually activity 1. In the figure, AB is parallel to CD, parallel to EF. So these three lines are parallel. See this? These three lines are parallel. AC is equal to 5.4. Okay, so let's write here. 5.4 is AC, CE is 9, and your BD is 7.5. So what is DF? Okay, find DF. This is the task. AB, CD, and EF are parallel, so we use property of three parallel lines and their transversal. So we have to mention this here, property of three parallel lines and their transversals. Okay, so this is the property we are going to use. So according to that property, we can write AC upon CE is equal to BD upon DF. Okay, but AC and C 5.49. Okay, from the given condition we have already mentioned here, and in this in this empty bracket we have to write DF. So BD value is 7.5. So we can substitute this value 7.5 DF. Okay. So we will take DF in LHS and take 9 and 5.4 to RHS. So 7.5 into 9 upon 5.4 is equal to what? This is the task for you, and the final answer is 12.5 unit. Here I am writing unit because in the question units are missing, so you can simply say unit. This is the answer. Activity 2. In this activity, there is one triangle, triangle ABC, and ray BD bisect triangle ABC. BD, this is the ray which bisect triangle angle ABC. It means this angle ABC. This angle is getting bisect by the ray BD. A dash D dash C. This is collinear point. These are collinear points because they lie on triangle on side AC of the given triangle. Side DE is parallel to side BC. DE and BC are the parallel lines. A dash E dash B. Again, A, E, and B. These are the collinear points because they lie on side AB of the given triangle. And finally, we have to prove AB upon BC and AE upon EB are equal. Hmm? Proof is already given. Only we have to fill in the blanks. Blanks space we have to fill. So AB upon in triangle ABC, ray BD bisect angle B. See ABC BD bisect this angle, which is a given. So according to angle bisector theorem, AB upon BC is AB upon BC is equal to AD upon DC. Okay, again AB upon BC is equal to AD upon DC. See the pattern. Okay, this is the first equation, first ratio. In second, in second case, we have to take again triangle ABC. Side DE is parallel to side BC. Since DE and BC are the parallel lines, and here we will use basic proportionality theorem. Okay, basic proportionality theorem. This is first theorem in this chapter. AE upon EB is equal to AD upon DC. AE upon EB is equal to AD upon DC. This is the basic proportionality theorem. So you have to write here basic proportionality theorem. Basic proportionality theorem. Okay. So now see, this is second number. This is the first number equation, second number equation. From these two equations, AB upon BC and AD upon DC. Here again AD upon DC. So RHS of these two equation is fixed, is constant, and LHS will equate. Okay. So AB upon BC. Here we have to write BC and AE upon EB. So here we have to write AE upon EP. AB upon BC is equal to AE upon EB. So very simple activity. Okay. Very simple activity, and this is the final answer. Let's solve practice set 1.2. First question. Given below are some triangles and the length of line segments. Identify in which figures ray PM is a bisector of angle PQ, QPR. Okay. If you observe carefully, QPR is the angle in this first diagram and PM is the bisector. Okay. Now whether it is bisector or not, that we have to find out. Okay. So what exactly we have to do? This is the question. The solution for this question is we have to use angle bisector theorem. So using angle bisector theorem, we can have a ratio like series MQ upon MR is equal to PQ upon PR. Therefore, now substitute the value. MQ is 3.5. Okay. MR is 1.5. PQ is 7 and PR is 3. If you multiply 3.5 into 2 and 1.5 into 2, then you will get 7 by 3. So this ratio is valid. Hence, you can say ray PM is bisector of angle QPR. Okay, this is the answer. So this ray bisect this angle QPR. It means these two angles are congruent. These are the identical marks. Understand what is going? Okay. So next, in the next figure, again PM is the ray which we have to check whether it bisect QPR or not. So take angle bisector theorem and write PM is equal to, or MP is equal to, MP upon MQ is equal to MP upon, I'm sorry, MR upon MQ is equal to RP upon PQ. So what is the value of MR? MR is 6, MQ is 8, and RP is equal to 7, PQ is equal to 10. 6 by 8 is equal to, the reduced form is 3 by 4, and 7 by 10 is 7 upon 10. Let's say 7 by 10 is 7 by 10, and 3 by 4 is 0.75, which is not equal to 0.7. Hence, ray PM is not bisector of angle QPR. QPR. Okay. For next diagram, diagram number 3, again apply angle bisector theorem, that is MR upon MQ is equal to RP upon QP. Substitute the value. MR is equal to 4, MQ is equal to 3.6. Here RP is equal to 10 and QP is equal to 9. QP is equal to 9. Therefore, 9 fours are 36. So we can write 4 ones are 4 and 0.9 fours are 3.6. So our answer is 1 upon 0.9. And here, if you take this 10 below this 9, so 9 by 1 upon 9 by 10. So I can have 1 upon 9 by 10 is 1 upon 0.9, and hence these two ratios are equal. Therefore, in this case, ray PM bisects angle QPR. This is the answer. Example 2. In triangle PQR, PM is equal to 15, PQ is equal to 25, PR is equal to 20, NR is equal to 8. So let's put those values. NR is equal to 8. PN is equal to, no, we don't know what is PN. So let's put question mark again. PM is equal to 15. 15. PQ, entire PQ, here it is. Here. Entire PQ is 25. Okay. And PR, this PR is 20. The entire PR is 20. And MQ is again missing. So this MQ is missing. So these things only given. Now state whether line NM is parallel to side RQ or not. Okay. And give reason. So how to find whether line NM and line RQ are parallel or not? Tell me. It is using basic proportionality. Okay. So using basic proportionality theorem, every time you have to mention which theorem you are going to apply. Using basic proportionality theorem, we can write ratio. Now we have to write ratio Pn upon Nr is equal to Pm upon Mq. But here Pn and Mq are missing, and that we can get using equation PR is equal to Pn plus Nr, as PR is 20, Pn we have to find, and Nr is 8. So Pn is equal to 20 minus 8, it is 12. Also we can get Mq using PQ is equal to Pm plus Mq. So MQ is equal to PQ minus PM. So PQ is 25. Here it is. PQ is 25 minus PM. PM is 50. Very easy. It is 10. So finally MQ and PN we find. Okay, MQ and PM. So Pn is now 12. So 12 upon Nr 8 is equal to Pm is 15 upon Mq is 10. So in the reduced form we get 4 2s are 8, 4 3s are 12. So 3 by 2 is equal to, again, 5 2s are 10 and 5 3s are 15. So again 3 by 2. Therefore, LHS left hand side is equal to RHS right hand side, and line MN. From this result, we can conclude a line NM is parallel to side RQ. Okay, this is how we can solve the given problem, and the reason is according to BPT, basic proportionality theorem. Okay, that we already mentioned in the beginning. Thank you. Question number 3. In triangle MNP, NQ is the bisector of angle N. See this, NQ. NQ is the bisector of angle N, this entire angle N. And if MN is equal to 5, PN 7 and MQ is 2.5, then find QP. So QP, how to find QP. As this is the case of angle bisector theorem, we can use it to take in order to find the ratios. So Q, let us see, QP upon QM, then I can write Pn upon Mn. Okay, Pn upon Mn. So this Qp upon Qm is equal to Pn upon Mn. Okay, so just substitute the value, very easy. Exercise is this. As QP we don't know, so QP will remain as it is. QM is equal to 2.5. QM is equal to 2.5. Pn is equal to 7 and Mn is equal to 5. Therefore, QP is equal to 7 into 2.5 upon 5. So 7 upon 5 into 5 by 2. So 5 get cancelled and 7 by 2, which means 3.5 unit. This is the answer for this question. Okay. So our QP is 3.5 according to angle bisector theorem. Question number 4. Measure of some angles in the figure are given. Prove that AP upon PV is equal to AQ upon QC. Here angle APQ is 60 degree and angle PBC is again 60 degree. So we have to prove that this ratio is equal. Then how to prove? Okay. Here we can use angle basic proportionality theorem, but for that PQ must be parallel to BC. Okay, so first of all, this is our first task to prove this PQ and BC are parallel to each other. How to prove this? If you observe carefully, angle P and angle B are congruent angles. So, and their congruency is because of corresponding angle. Okay, so 60 60, these are the two angles which are congruent because of their pair of corresponding angles. Okay, hence we can say PQ and BC are parallel to each other, and if they are parallel, Then we can apply basic proportionality theorem and we can prove that AP, PB and AQQC are the equal ratios. Okay, so let's solve this. Solution. Here, measure of angle APQ is equal to measure of angle PBC. This is because angles of equal measure. Okay, from figure we can write. Now, segment PQ is parallel to side BC. Okay, so why I am writing this? So it is according to corresponding angle test. Corresponding angle test. Okay, so according to corresponding angle test, if these two angles are congruent, then PQ and BC are parallel. Okay, now once these two sides are parallel, we can apply basic proportionality theorem. So according to basic proportionality theorem, here I am using short forms, but you have to write full form. Okay, basic proportionality theorem. Don't write BPT only. Yeah. So from BPT we can say AP upon PB is equal to AQ upon QC. Okay. So this is what we have to prove. So hence proved. In example 5, trapezium ABCD is given and side AB, EQ and DC are the parallel to each other. Okay. And AP is equal to 15, PD 12, QC 14 and BQ have to find. So AP is 15, PD is 12, QC is 14 and BQ is equal to what? Hmm? So how to find this? Which theorem we can use here? Okay, this is the case of parallel lines and the transversal. Look at carefully. AB, PQ and DC are the parallel lines. This is given. But AD, if we take AD and BC, then these are the transversal. Okay, and APD, BQC are the intersect. Okay, such type of things we already learned in this given in the theorem called property of parallel lines and their transversal. Okay, so it's the same thing we are using here, and according to this property, the property of parallel lines and their transversal, we are going to find BQ. Okay, so let's find it. According to property of parallel lines and their transversal, we can use or we can write AP upon PD is equal to BQ upon QC. Okay. Therefore, now substitute the value. AP is 15, PD is 12, BQ I have to find, and QC is 14. Therefore, BQ is equal to BQ is equal to 15 into 14 upon 12. Okay, so 6 2s are 12. So 6 इथे लिहायला आपल्याला 6 2s are 12 and 7 2s are 40. पुढे 6 ला पुन्हा आपण 15 and 6 डिवाइड करूया. 3 2s are 6 and 3 5s are 15. So 5 into 7 upon 2. It is 35 upon 2, which is 17.5. Okay, as units are not given, we can write simply unit. So 17.5 units is the answer for this problem. Question 6. Find QP using given information in the figure. Okay, here Mn is 25, Mq is 14, QP have to find, and NP is equal to 40. Okay, so this is the case of angle bisector theorem. So we can directly apply here. Solution according to angle bisector theorem. We can write MQ upon QP is equal to NM upon NP. जर तुम्ही इथे हे रेशो घ्यायला चुकलात तर तुम्हाला ह्याचं प्रॉपर आन्सर मिळणार नाही. त्यामुळे हे रेशो कसे घ्यायचे हे मी मागच्या लेक्चरमध्ये तुम्हाला जे तेव्हा थेरम शिकवलं होतं त्यावेळेला सांगितलंय. तो पुन्हा तो एकदा व्हिडिओ जाऊन बघा जर तुम्हाला हे समजत नसेल की हे कसे घ्यायचे, सिलेक्शन करायचे ते. अदरवाइज इट इज ओके. सो MQ upon QP. MQ किती आहे? इट इज 14 upon QP is equal to NM is 25 and NP is equal to 40. ठीक है. Therefore, QP is equal to 40 into 14 upon 25. This QP comes out here, 40 goes there, and 25 comes out here. So 5 5s are 25 and 5 8s are 40. So 8 into 14 upon 5. So 14 8s are 112 upon 5, and finally QP will be 22.4 units. This is the answer for this question. Question number 7. In the figure, if AB parallel to CD, parallel to EF, then find X and AE. Okay, X we have to find and AE we have to find. How to find? See, after getting X means CE, we can find AE by adding AC plus CE. That we can do. Okay, AE can be find using AC plus CE. Okay, so AC is 12, CE is X, and X we have to find. We don't know what is X. Solution. Here you observe three parallel lines. So this is the case of property of parallel lines and their transversal. Therefore, according to property of trans parallel lines, property of parallel lines and their transversal we can write AC upon CE is equal to BD upon DF. Okay, very straightforward sums. AC is 12, CE is X, BD is 8, and DF is equal to 4. By cross multiplication, 12 into 4 upon 8, we will get X. So 4 ones are 4, 4 twos are 8, and 2 ones are 2, 2 six are 12. Therefore, X is equal to 6 unit. X is equal to 6 unit. If we sub X means what? CE. Okay. So CE is equal to 6 unit. This is one answer, and the remaining answer is AE. So AE is equal to 12 plus 6, which is 18 units. Okay. So these are the two answers. Okay. This is one, and this is another one. And X